Sir, go ahead, sir.
Yes, sir. Thank you, sir. Yeah. So good morning once again. Today my topic is permutation as well as combination. Let me discuss about first permutation. Okay. Please, if you want to note it down, because this is pure theoretical one, permutation. This is nothing but arrangement. Listen carefully. Arrangement. I'll ask a few questions in between of this theoretical content. Permutation means it is arrangement or number of ways. So you can talk like how many number of permutations. You may get question like this. How many number of arrangements? How many number of ways? Right. Now here, arrangement, how this arrangement takes place. Number one. See, I have 10 items. 10 items. Out of these, I want to take 3 items and then arrange. This can be done as 10p3. P stands for permutation. Following my point? P stands for permutation. Now 10p3. Suppose 20 items are there. I want to take 5 items. Your answer is 20p5. So this is called expression. How to express it in mathematical way. Sir, how to simplify? So simplification part is later, right? See, now I'm taking all items. It is nothing but 10p10. Here also 20p20. So what I want to say that taking few items, right? Few in the sense smaller. So out of n, right? Your expression is number of ways is equal to, right? NPR. The formula is n factorial by n minus r factorial, right? Factorial means successive reduction. Are you following my point? Right. Now here is, okay. Okay, now similarly, out of n items, taking all items, all in the sense n, number of ways is equal to npn. Let me substitute in the place of Rn, n factorial by n minus n factorial, right? It is absolutely n factorial because 0 factorial is nothing but 1. Now remember these two rules, but you cannot make use of the rule. Simple simplification. For example, 10p3 should not use formula. 3 is there in the bottom, so 10 can be reduced 3 times. That's all. Following? Following? Yes, all of you?
Yes, sir.
Yeah, so the concept of permutation is taking few things, taking all the things at a time. If you take few things, then arrange. If you take all the things, then arrange. That's very simple. Is it right? Following? Great. See, we discussed about permutation clearly. For example, I'll take one more. I have 5 people. I want to take 2. So answer is 5p2. Simplification, 5 into 4, nothing but 20. How have written 5 into 4? Because 2 times. Is it right? Follow my point. See, all out of 5, if I want to take all, it is nothing but 5 factorial. 5 factorial is nothing but 120. Remember this one directly. 5 into 4 into 3 into 2 into 1. 26, 120. Right? Just remember this one. Suppose if you want 6 factorial, it is nothing but 6 into 120. You can write 720. Right? Few things you need to by heart. So here, need to remember the formulas and also simultaneously remember how to simplify in a simple way, right? So this is called permutation, right? Now let me talk about the types of permutation, right? How many types of permutations are there, right? Okay. Fine. Now here, types of permutations, we'll talk about types of permutations. Right. Number 1 is called dissimilar permutation, dissimilar arrangement, whatever it may be. See, let me take the example. Whatever you take, you have to take few things or all the things. That is the concept of permutation. You need to take less, you need to take everything. Now, suppose I'll take one example. From the word Monday, how many number of arrangements can be taken by 3 letters? What is the concept, Amma? Right? Monday, how many letters are there? 6, 3, 3. Out of 6, we are picking 3. So the answer is 6 into 5 into 4, very clear, 120. For example, from Monday, take all the letters of the word Monday. What is the answer? 6 factorial. So 6 into 120. 120 means what? 5 factorial. So it is nothing but 720. I hope you understood these two. Wherever you go, you have to take few things, all the things at a time. Following? I hope you understood the dissimilar arrangements. Now let's talk about the similar items. Now, similar items. Fine. Okay. Now here, similar permutation. Okay. Right. In similar permutation, we don't have the model of taking few letters of the word. This model you don't find. Following my point? Taking all the letters of the word, like for example, Mr. Jeevan, right? Taking all the letters of the word Jeevan. How to do this one? How to identify, first of all, similar? Here, we find 2 letters are repeated. Here, no letter is repeated. That's what this comes under dissimilar. Are you following my point? Yes?
Yes, sir.
Yes, sir.
Right, Amma. See, it's easy to identify similar and dissimilar. Now, in this model, the rule is total items factorial divided by like terms factorial, right? Total how many? 6 factorial. Like terms how many? 2 factorial. Then you simplify. That is 6 into 5 into 4 into 3 into 2 divided by 2. So simplify, it is nothing but 12, 30, it is nothing but 360. Following my point? Is it right? So it's easy to identify similar. So let me take one more example, right? Let me take one more example under similar. So we need to identify what is similar, what is dissimilar, right? In similar, we don't find the question which comes under taking few letters, right? Now, another one, mathematics. Is this comes under similar or dissimilar?
Similar.
Similar, sir.
Why? Because
Similar.
the rule is very clearly given. Total items 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me write 11 factorial by m repeated twice 2 factorial, a repeated twice 2 factorial, t repeated twice 2 factorial. Nothing is repeated. So my final answer is 11 factorial by 2 factorial whole cube. I hope you understood. Is it clear, all of you?
Yes, sir. Yes, sir.
Yes, sir.
We better do more number of questions tomorrow, right? After completion of this theoretical part, right? How to arrangement conditionally. Conditional questions are very interesting, right? So this is called permutation and types of permutation. I discussed about dissimilar permutation and a similar permutation. Let me go for another kind of permutation, right? So another permutation is circular permutation. Fine. So let me talk about circular permutation. So three types of permutations are there. One is dissimilar, second is similar, third is dissimilar, sorry, circular. So in similar, we can easily identify the given word, right? Now, circular permutation, right? In this number one, n persons arrangement in a circular way is equal to n minus 1 factorial. Second one, n persons arrangement in a circular way only in one direction. Rule is 1 by 2 into n minus 1 factorial. Right? Following? Now, let me explain these 2 points. What is the meaning of first one? First one is the straight one. N persons arrangement in a circular way. Suppose 10 people, if you want to arrange in a circular way, 10 minus 1, it is 9 factorial. Answer clear. Understood this one? Yes? Yes, Aman?
Yes, sir.
Yes, sir. Yes, sir.
Suppose if 20 people are there, what is the answer to arrange circular way? 19 factorial. If 15 people are there, what is the answer?
19 factorial.
Second point. Second point. N persons arrangement in a circular way only in, see, when one specific direction is given, you have to write off. Right? Half. Let me take one example clearly. Right? Let me take one example. See, I have 20 people. I want to arrange in a circular way. Suppose a dining table. They want to come and sit around the dining table. How they'll come? One person will come here, another person, again another person, some other like this. So totally at the end of the what you call time, all the people occupied their chairs. This can be done how many times? 19 factorial, because they do not have any direction. Any doubt in this one? Suppose if you ask them, all 20 of the people, if you please come in this direction or in this direction or in this, if you mention a particular direction, your answer is half into 19 factorial. Clear?
Yes, sir.
Clear, Amma? That's what in the
Yes, sir.
what do you call, many of the books you'll find only one which is very frequently asked in the exam. Only one example they'll give. For example, I'll give you. There are 30 flowers. How many ways can arrange in a garland? How many ways we can arrange 30 flowers in a garland? This is the question appeared in the exam. So what will be your answer? First of all, garland, see, arrangement means definitely this problem comes under permutation. Permutation, there are 3 types. One is dissimilar, second is similar, third is circular, right? But garland itself indicates as circular arrangement. Following?
Yes, sir.
Right. Then is it one direction or no direction?
No direction, sir.
No direction. How come? See, while making garland, you just observe they'll fix one end and they'll sending the flowers into that. The thread can be tightened at one end and they start to pushing the flowers into the garland. This is nothing but one direction. Following my point? I think you might have observed necklace beads. So while making necklace beads, right? So you just tight at one end and start pulling each and every beads. Is it right? It's called one direction. So definitely your answer is half into 29 factorial. Following? Half into n minus 1 factorial. I hope you understood.
Yes, sir.
So I completed permutation. What is permutation? Let me discuss once again. Permutation means taking few things, taking all the things at a time. You need to take few, you need to take all. If I take few, my answer is NPR. If I take all, my answer is NPM. Fine. And also we discussed very clearly how to calculate NPR, right? For example, 10P3 is there. So I'll write 10 into 9 into 8. It is nothing but 720. So this is a simple simplification. Similarly, we discussed about types of permutation. One is dissimilar permutation, where we'll find two models, taking few things, taking all, and similar permutation, taking few things model is not there, taking all the things is there. In circular, without direction, n minus 1 factorial, with the direction, we need to write half into n minus 1 factorial. Is it clear, all of you? Is it clear? So shall I go to, right, what do you call, next one? Combination. Okay, right. Let me go to combination. Fine. Now, combination, which is very similar to permutation, but slightly different. What is the meaning of combination? I said permutation is nothing but arrangement. What is combination?
Combining.
Huh? Combining.
Selection.
Exactly, Jawad. Selection. Combining also, I think, which gives the similar meaning. Nice. But pakka meaning is selection. Combination is nothing but selection. Absolutely. Right? So, what are the things are there? First of all, we'll talk about this. Right. It is also similar to permutation. Let me write. Out of, this is nothing but selection, Amma. It is nothing but selection. It is nothing but arrangement. Right. Out of n items, take few. Few means small r. Number of selections, I'm talking about combinations, is equal to NCR. C stands for combination. P stands for permutation. What is the rule for NCR? N factorial by R factorial into N minus R factorial. Next, out of N items, right? Take all items like N. Number of selections is equal to NCN is equal to, instead of R, I'll write N. N factorial by N factorial, N minus N factorial gets cancelled. 0 factor is nothing but 1. 1 by 1 is nothing but 1. I hope you understood. Clear? Clear, all of you? Now, same thing, Amma. In the previous case, we specified with the word of arrangement where we used P, here we used C, right? But the rule is different. Last time, I think we do not have this one. Only n factorial by n minus r, this one. But let me talk about this one. For example, 10 people are there. I want to select, not arrange. Select 3. So the rule is 10C3. How to write this one? 3 is there. I'll write 10 into 9 into 8 upon 3 into 2 into 1. Right? Denominator also we have to write. In the previous case, we have not written denominator. Is it right? So out of 10 people, if I want to take all, your answer is 1. Why? Because only 1. Any people are there, like 100 people are there. I want to take all of them. I want to select all of them. How many types? How many selections? Only 1. What is the meaning of this one? What is the meaning of this one? Come on.
Select all of them.
Suppose 20 people I want to take. I want to select 20 people out of 20. My answer is 1. What it means?
1
What
by
it
0
means?
is equal to
There is only one way to select.
There is no, one person is coming. There is no, come on. See, suppose 50 people are there. I want to select all the 50 people. How many selections are there? 1. Is it right? So 30 people are there. I want to select, not arrange. I want to select all 30. How many ways? 1. Yes, please talk to me.
1.
1 only, right? See, whenever you are going to take all the people at a time, when you are getting 1, the meaning of this one is nothing but there is no types of selections. Whatever the selection you take, you are getting 1 only, right? When you are going to take all the people. So no types of selections. In the previous case, types of permutations we discussed. One is dissimilar, second is similar, third is what you call circular. Now here, no types of selections. So let me go through one wonderful example under this selections. Is it right? So I said very clearly once again, out of n items, yeah, out of n items, it's NCR. If you take all NCR means this is a formula, NCN is 1. Okay, let me take one example. Fine. Right. I think you understood clearly the concept behind this. Is it right? Emma, all of you?
Yes, sir.
Great. Now I'll take one example because I don't have the types of this one. So how to understand this selection, how to select the people, few or more, right? So great. Now, let me talk one example. Listen carefully. Out of, right, 6 men and 5 ladies, to select a committee of 5 people, such that number 1, there is exactly 1 lady. Number 2, at least 1 lady. I'm taking the possibilities. Number 3, majority of ladies. Okay, majority of ladies. Great. All of you listen carefully. At the end of this problem, please tell me whether you understood or not. Right. Hope you are comfortable, all of you.
Yes, sir.
Yes, sir.
Okay, ma? Yes, please. Yes, all of you.
Yes, sir.
Yeah, very good, Amma. Very good. Right. Very good. Screen is visible.
Yes, sir.
Yes, sir.
Let me start. Out of 6 men, 5 ladies, you have to select 5 people. Right. What is the first condition? Exactly 1 lady. I'll take 1 lady from here. How many members I have to pick from men?
4.
Huh?
4.
4.
Because we have 5 people and we have 5 people. Yes, I'm getting noise. Please mute your volume, please. Mute your volume. Those who are getting, see, this is, I'll just abruptly stop this session if you do like this. Right. See, this can be expressed as 6C4. That means out of 6, I'm selecting C4 into 5C1. Into is nothing but and. Wherever you find and means into, or means plus. You just remember this one, right? Following the simplification. 6C4 or 6C2, which is similar, into 5C1, right? So 6 for differences 2 I have written. Calculation 6 into 5 by 2 into 1, 5 by 1. So this is 3. 25 3s are 75. Answer clear. Understood this one?
Yes, sir.
Yeah, all of you, boys and girls.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Great.
Sir.
Great. So shall I move to the second one? At least one lady. Let me talk second one. At least one means, what is the meaning of at least one? It may be more.
One and more.
One and more.
I'll
Yeah.
take 6 men and 5 ladies are there. 1 lady, 4 men. 2 lady, 3 men. 3 lady, come on. How many?
2 men.
2 men, great. 4 ladies, how many?
1 man.
1 man. Don't worry about this, right? Only 1 man. Don't scare about these people, right? Great.
5 ladies, 0 men.
5, 0. So will it be acceptable?
Yes. Yes, sir.
Because total must be 5 and 1 lady is there. That's enough. We don't bother about men. Why to bother about men, right? So now, how to express it? This one, 6C4 into 5C1. This is one kind of selection, right? Or I'm writing plus, right? 6C3, okay? 6C3 into 5C2 and so on. I think you understood clearly. Atama? Following?
Yes, sir.
Expression part I'm telling, so that you can express it and get the answer easily, right? Sometimes they leave the answer like this only because sometimes when you find huge what you call steps, they leave like that only in terms of C, right? Let me go for third point, that is majority of ladies. So you should find a majority of ladies. Whatever the selection is there, you should have to find majority of ladies, right? So ladies number must be more, like India, right? Following? Do you know that in India, female and male, what do you call, earning capacities or like 3:2? Do you know that? What is the meaning of this? What is the meaning of this? If
Majority of female is more
not
than
majority, earning, I'm talking about earning. If male earns
Female
2
earning
rupees,
is
female
more.
earning 3 rupees, right? So they're always great, right? I'm not going to suppress male. This is the fact I'm talking, right? Great. Now, see here, majority of ladies. Shall I take 5 and 0 here? First one.
yes, sir.
Yes, Jawad. Shall I take like this?
Yeah.
Shall I take
Yes,
like
sir.
Shall I take like this?
No, last one, no, sir.
No, because majority goes to men.
Yeah.
6 is 0 into 5C1 or 6C1 into 5C4 or 6C2 into 5C3. If you simplify, you get the answer. See, combination, selections, there is no types of selections. Then how the question will be, just I want to test you, right? So I hope you understood. Shall I give one more example?
Sir, 60
Yes.
Yeah, we'll try for another example. Great.
సార్ ఓన్లీ ఎగ్జాక్ట్లీకే అండ్ ఎందుకు తీసుకున్నారు సార్?
And in the sense, both, whenever you want to merge the people, I want 4 men, one lady, and you need to take, right? I want 4 men and 1 lady, definitely, and I have to take and 1 lady. See, that itself indicates while talking, right? Great.
Okay.
Now let me take one more example clearly. Listen carefully. Out of 15 cricket players, 4 are bowlers. To select a cricket team, there must be 2 bowlers. How many number of ways you can select? Can you tell me the answer? Procedure? Yeah, let me continue.
11C.
Out of 15 cricket
11C
players,
9.
there are 4 bowlers.
11C 12.
Remaining 11 are general players. Following? Following? All of you clear up to this?
Yes, sir.
Yes, sir.
Yes, sir.
To select a cricket team, that means I want to select 11 people, right? I want to select. So what is the meaning of this one? 11 people. How to select 11 people? 11 members I need to take. There must be 2 bowlers. So bowlers must be 2. Remaining 9 people from these general players. I will write 11C9 into 4C2. Is it clear, all of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
11C9 also can be written as 11C2 because it is different. Simple simplification, right? So 11 into 10 divided by 2 into 1 into 4 into 3 divided by 2 into 1. So my simplification, right? It is 30, 33 into 10, 330 is the answer. Clear? Clear?
Yes, sir.
Yes, sir.
I think you understood. So I successfully completed what is permutation and the types of permutation, what is combination and the types of combination. Is it clear, all of you?
Yes, sir.
Right? Good. So let me move to the next one, that is called probability, right? So I'll give the theory part of this within 5 to 10 minutes, right? Then we'll stop it. And then tomorrow we practice whatever the things we covered under permutation and combination. Is it right? If you want, if I prepare the paper of permutation combination, I'll try to share in the group so that better you get ready with the printout so that it's easy to interact with me tomorrow in class. Right, Amma? Right. Fine. Let me go through probability because it is connected with the probability. It is connected with probability. Permutation combination is a wonderful one, right? So permutation combination are the sister concerns of probability, right? Without permutation combination, there is no probability, first of all, right? Fine. So I write probability. Fine. Now, what is the meaning of probability? This is, I said, arrangement. It is, I said, selection. What is probability?
Possibility.
Ma?
Possibility.
Probability. Okay. Still more clarity. Yes. Absolutely, it is a chance, right? Clear, all of you? It is a chance.
Yes.
For example, I have a coin, so which is having tail and head on both sides. If I toss a coin, I may get tail, I may get head. I don't know exactly what will come. That is nothing but chance, right? It is completely hypothetical topic, imagination, right? That's what Indian government is using this probability in all the cases. Probability can give the accuracy sometimes, not sometimes, in all the times. Now, tail and head. For example, what is the probability of tail when a coin is tossed? What is the probability of head when a coin is tossed? Tail. One possibility out of 2. I write 1 by 2. One possibility out of 2. I write 1 by 2. Strictly speaking, what is the probability of any event? Event is equal to number of favorable, right, event by number of experiments, right? That means experiments what we are doing favorable, which is convenient to us. What is our favorable event? Here, if you take in this one, what is our experiment? We are tossing a coin. So I have taken as 2 power 1. Why 2? Coin is nothing but 2 outcomes. So if 2 coins are tossed, I'll write 2 power 2. If 3 coins are tossed, I'll write 2 power 3. I think you understood. Yes, please.
Yes, sir.
Yes, please.
Yes,
Right.
sir.
Yes, sir.
So, getting what is our favorable event? Tail. How many tails are there? Only one. So answer clear. So remember, the definition part of probability is what, simply speaking, that because we don't find definitions in the competitive exams, right? It's not academics. Define probability, they don't ask. So remember, what is a probability means? Number of experiments, number of favorable events. So what we are doing, what we are getting. That's all, simple. Now, let me take one more example, right? Let me take one more example. If I go to, like, fine. Suppose, definitely if you look at that, probability, what you call value, it must be less than 1. It must be less than 1. Less than 1 means it is not negative. It must lie between 0 and 1, right? Probability value lies between 0 and 1, right? In between this. It won't be false and negative. It must be more than negative. Sometimes probability may be 0. Sometimes probability may be 1. So when it will happen, look at, listen carefully. I have a coin having both sides tail. This is my coin. Understood? Understood?
Yes, sir.
Yes, sir.
I have a coin, both sides tail. My question is, if a coin is tossed 2 power 1, what is the probability of getting tail? So how many tails are there? 2. It is nothing but 1. So this is called certain probability. That is called definite probability, because no question of the meaning of chance here. If you toss a coin, definitely you'll get tail. So you'll get 1. Suppose in the same question, what is the probability of head? 0. Why? Because if you toss any number of times, you don't get head. This is called impossible probability. Impossible probability. So these two cases are very rare, right? Remember this one. So I completed what is probability, definition of probability. Follow my point number, right? So let me continue with another event. Now we are discussing about coin, right? Let me talk about another event. Fine. Okay. Now coin is nothing but what? If a coin is tossed 2 power 1, if 2 coins are tossed, what is that? What is that?
2 power 2.
Four outcomes.
Yeah, 4 outcomes. What 2 means 4 outcomes. If one coin tossed 3 times, also 2 cube. See, a lot of difference, no difference in this one. When one coin tossed 3 times or 3 coins tossed at a time, both are same, right? So remember all these things. So this is nothing but probability definition part. Probability value always less than 1. It lies between 0 and 1. Now let me talk about die. Die means, I think we'll find like this, right? We'll find like this. Following? How many faces are there in die?
6.
Yeah. So when a die is rolled, this is our experiment. Denominator comes 6 power 1. I think you are clear. When a coin is tossed, I have written 2 power 1. Why we used 2? There are only 2 possible outcomes. Here 6 possible outcomes. What is the chance of getting? What is the chance of getting? Right? 4. 4. How many 4s are there? Only 1. That is 1 by 6. Don't consider this is a number. How many 4 holes faces are there? Only 1. Clear? Now another one. A die is rolled. Chance of getting even number. Come on, a die is rolled. What is our experiment? 6 power 1. Even number. How many even numbers are there? 2. It may be 4. or 6. So 1 plus 1 plus 1. 1 chance, or means plus 1 chance. It is 3 by 6. Answer 1 by 2. Clear all of you?
Yes, sir.
Right. Another question. Right. A die is rolled. A die is rolled. What is the chance of getting prime number? What is the denominator here? 6 power 1. How many prime numbers are there from 1 to 6? Tell me.
3, sir.
2,
3.
2, 3, 5.
5,
5.
3. So 1 by 2. I think you understood when when a coin, a die is rolled, we have taken 3 models. Following? I think denominator is 6 because we find 6 possible outcomes. In the coin, 2 possible outcomes, right? So remember one point. See, in probability, sum of the experiments must be equal to 1. It's a wonderful point to do the problem in short method, right? Sum of the probabilities must be equal to 1, right? I'll give you example also. For example, I'll take coin. Probability of head, 1 by 2. Probability of tail, 1 by 2. Sum is equal to half plus half 1. We'll go for die. What is the probability of getting 1? 1 by 6. Probability of getting 2? 1 by 6. Probability of getting 6? 1 by 6. So sum is equal to 1 by 6 plus 1 by 6 plus 1 by 6, 1 by 6, 1 by 6 plus 1 by 6 is nothing but 6 by 6, 1. So I would like to give one statement. Sum of probabilities must be equal to 1. Right? So this is expressed as P of E plus P of E bar is equal to 1. E is nothing but success probability. E bar is nothing but failure probability. It is also called as occurrence probability. This is called non-occurrence probability. Following? See, when I know this success probability, I can calculate failure. How come? 1 minus this one. If I know this, I can calculate this. Follow my point? So I said 3 points. One is probability means what we are doing, what we are getting. Second is probability value lies between 0 and 1. If it is 0, that is impossible. If it is 1, that is what definite probability. Sum of probability must be equal to 1. Following? So this is the story what I want to cover today session. Tomorrow we extensively go with problems. Following? Yes, understood all of you?
Yes, sir.
Emma?
Yes, sir.
Yes, sir.
Great, Emma. We meet tomorrow, and today, if possible, I'll be in touch with you through group. Is it right? Because many things I want to discuss with you. Great. Okay, Emma, thank you very much. Anyone joined yourselves? Right. Great. There is no session now. Please, I'm going to wind up this session. Thank you very much. Right.
Thank you, sir.